Good morning, student. Good morning to all of you. Today we are going to discuss a topic that is magnetic field due to semicircular wire. Okay. Let us see here. Suppose this one semicircular wire. Okay. And inside the semicircular wire there is a current which is flowing. Okay. And we have to find out this semicircular wire. There is a magnetic field will be at a point P. Suppose this one a point P, which is the center of this semicircular wire. At this center, we have to find out the magnetic field due to this semicircular wire. For the sake of simplicity, we use the Biot-Savart law to find the magnetic field due to the semicircular wire. What is Biot-Savart law? Let us see here. Suppose this one wire, and inside the wire, this one the straight wire, and inside the straight wire there is a current which is flowing, and we have to find out the magnetic field due to this elemental current, that is dl, at a point P, which is the position vector, that is r. R is the position vector from the center of this dl elemental current, and this dl makes an angle theta with r. So due to this dl there is a magnetic field db. The db becomes how much? Mu naught upon 4 pi I dl sin theta upon r square. This is the Biot-Savart law. We use this law to find the magnetic field at a point P. This is the center of the semicircular wire. Suppose we cut an element having a length of dl, and this element having a direction which is tangentially to on the curve, that is semicircular. We see that the current is always in the direction of dl, or we can say that the dl is always in the direction of current. Here the dl is always in the direction of current because dl is an elemental current. Okay. We say that here that this one the r, here the distance between the dl and point P, this is the distance between dl and point P, and the distance is called the radius of this semicircular wire. We assume that the radius is here a. So here we see that the angle becomes 90 degree. Okay, here the angle becomes 90 degree because the dl and r is perpendicular to each other. Here the dl and r is makes an angle theta, and but dl and r is here 90 degree perpendicular to each other. So for the dl there is a magnetic field db here. Due to this dl there is a magnetic field db. So we find that db becomes how much? Mu naught upon 4 pi I dl sin theta, that is 90 degree because theta here 90 degree. So upon a square, a is the distance between dl and I. Okay. Again, we know that the sin 90 becomes 1, and the db becomes how much? Mu naught upon 4 pi I dl upon a square. Okay. This is the way the direction of this db. In the we put the thumb in the direction of electric current, and we curl our hand, our curling fingers will indicate the direction of magnetic field. As you put the dl, as you put the thumb in the direction of electric current, our curling fingers will indicate in the inward direction. Let us see here, inward direction. So the direction of this db becomes inward. Okay. We cut an element here also. This one the direction of db. Okay. This one the direction of db. Sorry. This one the direction of dl. We cut an element dl here. This one the direction of dl, and here we see that the distance between dl and endpoint P, that is also perpendicular here also. Distance between dl and P. The angle between the dl and r is also perpendicular 90 degree here. We cut an element also here. We see that this one the direction of dl, okay, and this one the r. We see that also perpendicular. And with the direction of this db here, we place our thumb in the direction of electric current because the electric current is like that. Okay, we place our thumb in the direction of electric current and curl our fingers. The db is also in the inward. Okay, Here we see that inward, we place our thumb in the direction of electric current and dV will go inward. So the direction is same for all element, so we can integrate here. We integrate this dB for semicircle. If the direction is not same, then we cannot integrate, but here the direction is same, so we can integrate semicircle. Okay. As we integrate, we find that the dB becomes how much? So the dB becomes B. Okay. Here the dB becomes B. After integrating, the dB becomes B mu naught upon 4 pi I upon, and that is the mu naught upon 4 pi is a constant, so it will come out, and I and A also be constant. I, the current which is flowing inside the current inside the wire, that is constant, and A is the distance between the DL and A, always constant, because it is the radius of this semicircular wire, so it comes out, and inside the wire it is dA for semicircle. Okay. As we integrate the dl, we get the circumference of the semicircle. Okay. As we integrate the dl, we get the semicircle circumference of the semicircle, dl. Okay. This one becomes mu naught upon 4 pi I upon A square, and circumference of the semicircle pi r square. Here r is A. Okay. Sorry, pi r. Okay. This one pi r. The circumference of the semicircle is pi r, because the circumference of the complete circle is 2 pi r. So the circumference of the semicircle becomes pi r. Okay. This one A square. Okay. The A square will be cancelled out. The pi also be cancelled out, and the B becomes how much? Mu naught upon 4 I upon A. This one the direction, this one the magnitude of magnetic field at the center of the semicircular wire, that is inward in direction. Okay. Inward. I think you are able to follow me. Thank you very much.